everyone, my name is Khushi Sharma. Today the topic I have chosen for the demo is trigonometry. Trigonometry is a very insightful concept of mathematics. Before moving ahead, these are the highlights of the lecture. In this lecture, I will introduce you to the trigonometry. What is trigonometry? How does it work? Some prerequisite knowledge like angle measurement, how does we calculate the angles, then what is the trigonometric ratios? Trigonometry is based on the some ratios which are called trigonometric ratios. Further, some basic identities and numerical problems will be discussed in this video. Then, after discuss these all basic concepts, some brief knowledge of the trigonometry, we will able to understand the real world applications of the trigonometry. That that will answer our curiosity. Why do we need to study this topic, and what is the significance of trigonometry in real world applications? So, moving ahead, the first question of a student should be, what is trigonometry? As the name suggests, tri means three, gon means sides, and metry means measuring. That means this is a study of measuring three sides. Three sides means a triangle, but in fact, trigonometry is a study of relation between angle and sides of a triangle. Here we will study relation between the angles and sides of the triangle. Now, in the triangle we have three sides, three angles. Based on the measurement of sides and angles, we have studied various type of triangles like scalene triangle, isosceles triangle, equilateral triangles, isosceles, then at obtuse angle triangles, acute angle triangles, and the most studied right angle triangles. So here in the fundamental study of trigonometry and the introduction of trigonometry is mostly focused on right angle triangles. Here we will study only right angle triangles. As I told, we will going to study relation between angles and sides and right angle triangles, right angle triangles also. Then first we are required to study this right angle triangle and its property. What we have studied till now. So as per the definition, we all know in right angle triangle we have a right angle which is of 90 degrees and two acute angles. Here one angle is referred or denoted by theta, and suppose the second angle is theta dash. This is a right angle triangle ABC. So here we can say that theta 1, theta dash and theta are complementary angles. Why? By following the concept of angle sum. Angle sum of interior angles is 180 degrees in triangles, then 90 plus theta 1 should be must 180 degrees. From here we can conclude that theta plus theta dash sums 90 degrees. That means they are complementary angles. By providing this fact, we can calculate one unknown angle if other angle is given. And the other thing is that by considering the sides of the right angle triangle, we have a relation. Most common and most famous relation we all have studied, which is Pythagoras theorem. Pythagoras theorem, which gives us the relation between the sides of a right angle triangle. As we know, the highest, the biggest side is called hypotenuse, perpendicular, and the other are perpendicular and base. By Pythagoras theorem, we write perpendicular square plus base square is equal to hypotenuse square. Till now, we have studied the relation between angles between sides separately. By this, we can find one unknown angle if we are provided by a one acute angle, and by this, we can find one unknown side if we are given with two sides of the right angle triangle. But in trigonometry, we study the relation between angle and sides simultaneously. Trigonometry allow us Trigonometry allow us to study the whole triangle. It means all sides and all angles. As one angle is already known, we can talk about another two acute angles. Here we just require one angle and one side of any right angle triangle. And the trigonometry studies will give us the all measurements of the triangles, like all sides and one another angle. How does it work? It works on some ratios. In trigonometry, we have ratios of the sides. The ratio of two specific sides with respect to one acute angle gives us different relations and different informations. Before moving ahead, as I told you, our study goes around the angles and the sides. So we require to study angles and sides first. This is some prerequisite knowledge to study this topic. Angles and sides. As we generally measure, sides are measured in measurement unit centimeter, meter, or anything else. But what about angles? Some of you does not know about the angles measurement system. How does an angle measured? In this study, sometimes we found that angles will be negative also and positive also. How we differentiate it, negative and positive sign? So here is the explanation. Since we know about the side measurement, we focus on the angle measurement. As per the definition of angles, what is an angle? Angle is a measure of rotation of a ray with respect to its initial point. This is the initial point of the ray O. This is the ray OA. When it rotates, it comes to OB. Then this measure, how much it rotates, is called an angle. Now we can see rotation will be anti-clockwise and rotation can be clockwise also. Then to differentiate these different directions of rotation, we use negative and positive signs of measure to an angle. How? Suppose some examples to clarify this. This is our initial ray or initial line, we can say OA. If it rotates anti-clockwise and turns to OB, then this angle is measured as positive. The measurement of this angle is written as positive, and if this initial ray rotate in clockwise direction like this, if we measure an angle in clockwise direction, then the angle will be written in negatives. Suppose this is an angle of 30 degrees, but we have calculated it in clockwise direction. That's why we will write it minus 30 degrees. And suppose it is also 30 degree, but we have calculated it anti-clockwise manner, then it will be write as plus 30 degrees. And this line, which is the final position of your ray after rotation, is called terminal line. Hence, the angle between initial line and terminal line can be calculated clockwise or anti-clockwise also. That's how the sign of the angle is decided, whether it will be positive or whether it will be negative. Now, just see one example. Suppose here makes an angle. Now, if we calculate it in clockwise manner, then this is minus 90 degrees. But if we calculate it in anti-clockwise manner, then we will write plus 270 degrees. Here, we generally use degree measurement for the angle. But is that the only measurement system for the angles? No. Angles can be measured in many other measurement systems, in other measurement units like degree, minute, second, radian, and so on. First, generally we use the degree system. What is degree system? Degree system. In degree system, we call if an angle, we consider this whole revolution. This initial line rotates from there and take a whole revolution. Then we consider this whole revolution as 360 degree. If an angle is have measure, an angle have measure of 1/360th of an revolution, then it is called one degree. That means if we divide this 1 degree in 360 equal parts, then each part of this rotation is of 1 degree. This is degree system. Now we can further classify these degree angles or further divide these degree angles in sexagesimal system. Sexagesimal system is a system which is based on the number 60. Just like we divide 1 hour in 60 minutes, then further we divide 1 minute in 60 seconds. Similarly, if we divide 1 degree in 60 equal parts, then each part is of called of 1 minute. Minute is another measurement unit for angles. So here we can conclude 1 degree is contains 60 minutes, or we write it like a dash 60 minutes. Further, if we divide 1 minute in 60 equal parts, if we have one angle of 1 minute and divide it in 60 equal parts, then each part of this angle is called of 1 second. Second is denoted by this double dashes. Hence, we can say that 1 minute and 1 degree is of 60 minutes. 1 minute is of 60 seconds. With this relation, we can convert angles in our general units, which is degree. If we are given the angle in seconds or minutes, we can convert them by dividing or multiplying by 60 as per the relation suggests. 1 degree is equal to 60 minutes and 1 minute is equal to 60 seconds. Now here comes one another system, which is called radian system. Here we are studying angle measurement systems. The second system is well known system, circular or radian system. In this system, we define one angle measurement with a unit circle or any circle of radius. Here we say that the angle made by an arc, this is the arc of length is equal to the radius of that circle. It means the radius is r and the length of the arc is also r. Then the angle which is tangent to the circle which is made by this arc on the circle is of 1 radian. This is the sign in denotation of radian, 1 radian. Hence, the whole revolution is of 360 degrees. Then 360 degrees, how much radian will be 360 degrees? Here, if we take r as 1, then what is the length of this arc? Equal to the circumference of this circle, which is equal to 2 pi r. Then it means r, if we take 1 as unit, then the circumference is 2 pi. Hence 360 is equal to 2 pi radian. Here we can say 180 degree is equal to pi radian. Okay. From here we will get one more result to convert radian into degrees or degrees into radian. 180 degrees is equal to pi radian. This is the result we have got, then we can say that 1 degree is equal to pi by 180 radians. Then if we have x degrees, then how can we represent it into radians? We have the measure of 1 degree. Then the measure of x degree in radian is x by 180 into x radian. Let's take an example. Suppose we have an angle of 60 degrees. Then how much radian is called 60 degree? Here we have x is equal to 60. As this is 60 degree, in radian, we convert it using this formula. Pi by 180 multiplied by 60. Then this is pi by 3 radian. So in trigonometry, the angles are also measured in degrees and radian also. After this discussion, we are able to move on the base of the trigonometry. What is trigonometry? How the relation works? How the relation is given? We will study there. Moving on to the trigonometry ratios. As I have told, trigonometry is a study of relation between sides and angles, and this allows us to study the whole triangle with only one angle and one side required. How it works? So this is based on the ratio of two specific sides. Why I am using this specific sides? It will be cleared further in the lecture. Specific side with respect to with respect to an acute angle. And why I am pressuring this point with respect to one angle with corresponding to one angle? So here is the answer. Let a right angle triangle A, B, C and one acute angle called suppose theta. Now, according to previous knowledge, we name the biggest side as hypotenuse. This is called hypotenuse. Then the other two sides are can be named as perpendicular and base in any manner. One student can call this perpendicular and this as base. Some other student name this as base or this as perpendicular, but this only works in Pythagoras theorem. Here the description of the perpendicular and the base is decided with respect to the angle which you are considering. Corresponding to that, you are studying the trigonometry. If we are considering this acute angle, which is theta, then the side opposite to this angle is called perpendicular. And the side which is adjacent to this is also adjacent to this, but besides this hypotenuse, the other side which is adjacent to the theta is called base. So this is base and this is perpendicular. Now talk about the ratios. Using three sides, we can define some ratios like perpendicular with ratio hypotenuse, base upon hypotenuse, or perpendicular upon base, or base upon perpendicular, or hypotenuse upon base, or hypotenuse upon perpendicular. This six type of ratio we can define with these three sides of an right angle triangle. Now, in trigonometry, these ratios named is some trigonometric functions. These all ratios have a different significant name. Just sine theta, as we are discussing this side with respect to this point, here the ratio perpendicular upon hypotenuse is known as sine theta. Then the ratio of base and hypotenuse is named as cos theta. Now comes to the ratio of perpendicular upon base, which is called tan theta. Perpendicular upon base. These are the basic trigonometric ratios. Why I am calling this as basic? Because the other three ratios can be derived by reciprocal them. As if reciprocal sine theta, we have cos theta, which is the ratio of hypotenuse and perpendicular. If reciprocal the cos theta, we have sec theta, which is the ratio of hypotenuse and base. And if we reciprocal tan theta, we have another trigonometric function, another trigonometric ratio, which is cot theta, base upon perpendicular. So these are the trigonometric ratios which allows us to study the triangle more conveniently than our prior studies. So how it works? Because for some specific theta, it means for some specific measure of an angle, suppose 45 degrees, the ratio of perpendicular and the height, hypotenuse, is same. However, the size of the triangle, it doesn't matter. Why it doesn't matter? We can study this with this example. So the fact is, trigonometric ratios doesn't change provided the angle of consideration, the angle of consideration remains of same measure. Here I will explain this whole fact with help of this diagram. A, B, C, E, Q, R, S. These, in this diagram, we can clearly see three right angle triangles, triangle ABC, PQC and RSC. If we take the angle C as theta, then which side of these triangles considered as perpendicular? In the triangle ABC, perpendicular will be this side. In triangle PQC, perpendicular is this side, opposite to the consideration angle. And the triangle RSC, the perpendicular is this. And by a criterion of similarity, criterion of similarity of triangles, we can easily see that these three triangles are similar. So the ratios of their sides, corresponding sides, will be equal. Firstly, this ratio, side AC and side PR. We are considering these two triangles, ABC and PQC, and side PC is equal to the ratio of AB. This triangle is AB and this triangle it is PQ. From here, if you cross multiply this is AB upon AC and this is AB upon AC and PQ upon PC. What is this? AB upon AC. It means perpendicular upon hypotenuse. This means sine theta for the triangle ABC. And what is this? PQ upon PC. This is sine theta for the triangle PQC. Here we can say that sine theta for both triangles are same because the theta, the measure of this theta is same for both triangles. If it is of 65 degrees, then it is remains 65 degrees in both triangles, whether it is triangle ABC or whether it is triangle PQC or whether it is triangle RSC. Hence, we can conclude that the trigonometric ratios doesn't change if the angle of the consideration remains same. This allows us to study how. Suppose now we all know the ratio and relations. Suppose tan theta, here is AB or this is a right angle triangle and we have the measure of this side. This is unknown. I don't know what is this. And we have the measure of this angle. Suppose it is 45 degrees or 60 degrees. Let us go 60 degrees. Then how we define tan theta? This is AB upon BC, perpendicular upon base, where we know the value of AB, which is x, and BC is unknown. And this is tan 60 degrees. So in the trigonometric table, we have most of the, or we can say all of the values of tan, sine, cos, and all trigonometric function for different angles, or we can calculate the required values. If we have this value and this value, then we can easily find this. And once we have find two sides of this triangle using the Pythagoras theorem, we can also find this, or using another trigonometric ratio, we can also find this hypotenuse and this angle also. Now let's suppose till now I have considered only one acute angle. What is about the second acute angle? A, B, C. If I take this as theta, then the perpendicular will be considered BC. The side BC is perpendicular and the side AB will be base. The hypotenuse is always the biggest side. In this case, sin theta will be perpendicular upon hypotenuse. This is BC upon AC. But in the case of this theta, suppose this is beta, sin beta will be, now this work is, or this considered is perpendicular. Now this is perpendicular, which is AC upon, sorry, AB upon the hypotenuse. So for different angles, the ratios defined differently. That's why I am saying specific sides of ratios, because sides can be considered according to the angle of consideration. Now, moving on to some real life examples of trigonometry. What is the use of trigonometry in real life? Suppose here is a photographer and here is a tall building, and he had to take a photograph of this building. Then how can he find the distance, at which distance he should stand, and at what angle he should set his camera, so that he can click the picture of whole this whole building. So, and many other things like how microscopes work, how telescopes work, how astronauts use this trigonometry to decide the position of stars, to decide the position of planets. So trigonometry is widely used in real life. It gives us angle, heights, distance simultaneously. We just need one angle and one side of a right angle triangle. And in real life, there are significant cases where one right angle is formed. Whether you are standing at a building or looking at someone, what will be the distance between the foot of the building and the person? This can also find by trigonometry. If we have this angle, if we have the height of this building, then we have got one side and one angle. Now we can study this whole triangle by trigonometry. So this is the insightful use of trigonometry. Now moving on to some basic identities of trigonometry. The basic identities of trigonometry is based on Pythagoras theorem. In the trigonometric ratios, we have found some relations such that sin square theta plus cos square theta is equal to 1, and sec square theta minus tan square theta is equal to also 1. Third one is cosec square theta minus cot square theta is also 1. How can we prove that? These all can be proved by Pythagoras theorem. How? What is sin theta? Sin theta is described as ratio of perpendicular and hypotenuse. And thus, if we square that, it is perpendicular square upon hypotenuse square. And what is cos square theta? Cos square theta is ratio of base and hypotenuse. After squaring it, we have got this. Now, by taking LCM, we have got this. And according to the Pythagoras theorem, P, D, H, which is hypotenuse, perpendicular and base. Perpendicular square plus base square is equal to hypotenuse square. So this is one, as proved. Similarly, in sec square theta, what is sec square theta? Sec square theta is nothing but the reciprocal of cos square theta, which is hypotenuse square upon base square. What is tan square theta? Tan square theta is the ratio of perpendicular and base. Now, this is base square, and again with the use of Pythagoras theorem, we can say that this is nothing but base square, and this is also 1. Similarly, this property can be proved. Now, we are given some numerical problems. Suppose in some question, we are given with one trigonometric ratio, which is sin theta is equal to 3 by 5. But we are required to use another trigonometric ratio. Suppose we are required to use tan theta. So how can we find this? From there, we all know this is the ratio of perpendicular and hypotenuse. Using the ratio, let the perpendicular is 3x, x is a constant, and the hypotenuse will be 5x. For find this tan theta, we require perpendicular upon base. It means the measure of the base. Using the Pythagoras theorem, we can find base here. How? Base square is equal to hypotenuse square minus perpendicular square. Here hypotenuse is considered at 5x. Then square will be 25x square. And perpendicular is 3x. Then square will be 9x square. Here we have got base square as 16x square. Then the base will be 4x. Now come to the required solution, which is tan theta. Tan theta is the ratio of perpendicular and base. By putting these values, perpendicular as 3x and the base as 4x, we have got the required ratio, tan theta. Similarly, we can find another ratios like cot theta, cosec theta, sec theta, cos theta by just applying this method. Or if we are given with two sides of a triangle, we can easily find the third one. Suppose if we are given with perpendicular as 8 centimeter, base is 6 centimeter, then we can find hypotenuse, which will be 10 centimeter. By using Pythagoras, we can calculate it. 8 square plus 6 square hypotenuse square, which is 64 plus 36 is equal to root 100, which is 10. Hypotenuse is 10. Now we can define each and every trigonometric ratio. Sin theta is perpendicular upon hypotenuse, it means 8 by 10. Cos theta is base upon hypotenuse, which means 6 upon 10, and so on. But the thing is, how can we learn? How can we remember these ratios? That how these are defined? Such as, what is sin theta will be? This is impossible to remember these 6 formulas in just one lecture. So this is the trick. Just learn these expression and you will get all the trigonometry ratios. By first one, perpendicular upon hypotenuse, you get sin theta. Then base upon hypotenuse, you got cos theta. Base perpendicular upon base, you will got tan theta. So this is easy way to remember these ratios, how they are defined. Then just by reciprocal them. If you reciprocal the tan theta, it means b by p, base upon perpendicular. It will be defined as cot theta. If you reciprocal cos theta, it is defined as sec theta, which is hypotenuse upon base. If we reciprocal sin theta, it is defined as cosec theta, which is hypotenuse upon perpendicular. So this is for the this lecture, and this is the introductory lecture. We can solve the trigonometric problems by using advanced identities also. In next lecture, we can discuss advanced identities. But before moving ahead, we are required to learn these things. We are required to understand these basic concepts of trigonometry. Thank you.